Recursive functions. JavaScript allows you to call functions recursively. This is particularly useful for dealing with tree structures, such as those found in the browser DOM. So here they give us an example. We have a function named countChars. We have an argument elm inside of the parentheses. Outside we have curly braces. Inside of the body we're gonna have the if statement. We have an if statement. We have a local variable count, name count, initialized to 0. We have a for loop. Inside of the parentheses we have another local variable I, initialized to 0. And then finally we have the return count. So here in the if statement, inside of the parentheses we have elm.notype is equal to 3. If elm.notype is equal to 3, then we're gonna return elm.novalue.length. So here we have the let declaration, we have the local variable name count initialized to 0, and the for loop we say we initialize the local variable I to 0, comma, we have child, semicolon, in parentheses we have the child is gonna be assigned to that child node, open brackets, we're gonna pass this local variable I, close brackets, close parentheses, semicolon, and then we have the local variable I increment is gonna be incremented by 1. Then we have the count, the addition assignment, countChars. Inside of the parentheses we have the child here. So this is pretty much the same as saying that the count is gonna be assigned the count plus the countChars with this argument inside of the parentheses. We close the curly braces for the for loop, and then we return the count. Function expressions can be named as well, which allows them to be recursive. They give us another example this time. In this example they say function countChars, and in this one here we have const chars and body is gonna be assigned, and we open a parenthesis, and inside of this parenthesis, this one here, we're gonna have a function named counter. Inside of the parenthesis here we're gonna have an argument outside of that we have the curly braces, and we're gonna have an if statement. We're gonna have a let declaration, and we're gonna have a for loop, and finally the return statement. So the const declaration here, we are declaring this constant chars and body is going to be assigned to this function counter. The condition, if elm.notype is equal to 3, not assigned, but this time since we have a triple equal operator, is going to be equal to 3. If this is equal to 3, then return, and we're going to return the elm.novalue.length. We have a let declaration, we have a local variable name count, and we initialize it to 0. Close semicolon, then we have the for loop. Inside of the parentheses of the for loop we initialize another local variable name I is going to be initialized to 0, comma, we have the child, semicolon, and parentheses, the child is going to be assigned the child nodes, open brackets, we pass this local variable I, close brackets, close parentheses, semicolon, and then we have the local variable I incremented by 1. That is what it means, this plus plus. Outside of that we have the open curly braces, and we have the count, the addition assignment, counter, and we have the child inside of the parentheses as an argument. So it's gonna be the count is gonna be assigned the count plus the counter with the child as an argument. Outside of the for loop, we are gonna return the count. We put semicolon, we close the curly braces, we close the curly braces, we close the parentheses, we close this curly braces, and we close this parenthesis here. We started with this parenthesis before the function, we close it here, and then we open a new set of parentheses, and inside of that parenthesis we type in the document.body. The name provided to a function expression as above is only available to the function's own scope. This allows more optimizations to be done by the engine and results in more readable code. The name also shows up in the debugger in some stack traces, which can save you time when debugging. If you're used to functional programming, be aware of the performance implications of recursion in JavaScript. Although the language specification specifies tail call optimization, only JavaScript core used by Safari has implemented it due to the difficulty of recovering stack traces and debuggability. For deep recursion, consider using iteration instead to avoid stack overflow.